In this video, we're going to look at finding the points on a polar curve where the tangent to the curve is either parallel or perpendicular to the initial line. If we look at example 1, we have the spiral r equals e to the power of theta, and you can see there are 2 points, here and here, where the tangents are parallel to the initial line. And we're going to find the coordinates of each of these points. If we consider the Cartesian gradient of a tangent in terms of dy by dx, where this would be the x-axis and this would be the y-axis, then dy by dx at each of these points, the gradient will be 0. And we covered in a previous video that the polar equivalent for y is r sine theta. So to work out dy by dx, we need to use the chain rule. So this would be the product of dy by d theta and d theta by dx, because then you can imagine that the d thetas will cancel. And if this is equal to 0, then dy by d theta must equal 0. So to find the point on this curve where the gradient is parallel to the initial line, we need to find dy by d theta. And I'm just going to draw a box around that because that's really important. Okay? So if we start with y equals r sine theta, and we can substitute this in place of r, then we have y is equal to e to the theta sine theta. And we need to find dy by d theta. And we can do this by using the product rule. So u will equal e to the power of theta. We'll differentiate sine theta, and we get cos theta, plus v, which is sine theta, du, which is e to the theta. And we can set this dy by d theta equal to 0. And we can factorize out the e to the power of theta. So we get e to the power of theta multiplied by cos theta plus sine theta. And we can simplify this by dividing both sides by e to the power of theta. So 0 will equal cos theta plus sine theta. And to work out theta, we can move either of these to the left-hand side. We'll move sine theta to the left-hand side. And then we can divide both sides by cos theta. So minus tan theta will equal 1. We'll move this negative to the right-hand side. So tan theta equals negative 1. We'll take the arctan of both. So theta is equal to the arctan of negative 1. And we get theta equals minus pi over 4. But if we think about this on a tan graph, this negative pi over 4 will give us exactly the same solution at this value, which is 3 pi over 4. And the next solution will be here at 7 pi over 4. So at this point, our angle of theta is 3 pi over 4, and at the second point, it will be 7 pi over 4. So if we call this point 1 and this one point 2, so the first point on the curve will be when theta equals 3 pi over 4. R will then be e to the power of that angle, which is approximately 10.55. So the coordinate will be the radius and then the angle theta. Okay? The second point, well, theta is now equal to 7 pi over 4. So the radius will be e to the power of 7 pi over 4, which is 244.15. So the coordinate is 244.15 and then 7 pi over 4. Okay? And you can see that this looks about right from our graph. Okay? In example 2, we're going to look at where the tangent is perpendicular to the initial line. Okay, so in example 2, We still have the spiral r equals e to the power of theta, but this time we've been asked to find the points where the tangents are perpendicular to the initial line. So we're looking at this point here and this point here. And you can see that for each of these lines, because the tangent is perpendicular to the initial line, now we have dx by dy equals 0. And we covered in a previous video that the polar equivalent to x is r cos theta. So now we need to use dx by dy is equal to dx by d theta multiplied by d theta dy. Because again, these two d thetas will cancel, so we're left with dx by dy. And to make this equal 0, we need dx by d theta to equal 0. And I'm going to put a little box around that because that's important. Okay? So if x is equal to r cos theta, and we're told that r is equal to e to the power of theta, then we can substitute that into here. So x will equal e to the power of theta cos theta. And we need to work out dx by d theta, which we can do using the product rule. So we have e to the theta. The derivative of cos theta is minus sine theta, plus the derivative of e to the power of theta, which is itself cos theta. And we're setting this to equal 0. And again, we can factorize out e to the power of theta. And to make this a little bit tidier, I'm going to write the cos theta first. So cos theta minus sine theta. Again, we can divide by the e to the theta. So this time, tan theta will equal 1. We'll take the arctan of both sides. So theta will equal the arctan of 1. Theta will be pi over 4. So you can see that pi over 4 will be the angle at this point here. And now we can find the angle for our second point using our tan graph. So we've got pi over 4 about here. Our second solution will be at this point, which is 5 pi over 4. So if we label these 2 points, point 1 and point 2, we know for point 1 that theta equals pi over 4, so r will equal e to the pi over 4, which is approximately 2.193. So the coordinates at 1 are 2.193 and pi over 4. For point 2, theta is now 5 pi over 4. So the radius will be e to the power of that angle, which gives us approximately 50.75. So this will have the coordinates of 50.75 and 5 pi over 4. Okay? Okay, so I hope that it's given you an idea on how to find the points on a polar curve which are either parallel or perpendicular to the initial line. Thank you very much for watching, and I hope you found that useful. You can download the full lesson from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.